All right. Thanks, everyone. Yes, this talk is PANTS, Network Programming Made Easy. And PANTS is a framework/library that I've been working on for a little while, which basically aims to give developers a really simple solution to network programming, particularly servers that can also be used for clients. So network programming, in a sort of general sense, consists of getting your application to talk to another application over a network such as the internet. And in Python, this is done using the pretty ubiquitous Sockets API, which is a C library, and it's part of the standard library as well in Python. The thing about sockets is that they're very low level, and for someone that's not particularly familiar with them, they can be quite difficult to use correctly. So in much the same way that you would use a GUI framework rather than, say, a 2D graphics API to write a graphical application, you'll often choose to use a networking framework rather than deal with sockets directly. PANTS is such a networking framework. There's a few buzzwords up there. I'm going to go through them and explain what they mean. So PANTS is single-threaded, which is fairly obvious. All the work happens in a single thread of execution in a single process. This has pros and cons, but in many situations it's beneficial because multi-threading can be particularly challenging at times. It's asynchronous. So what that means is that everything in PANTS happens sequentially. There's no concurrency going on behind the scenes. And in Python, this is particularly useful because it helps you to build scalable applications with thousands of sockets going on at once. It's event-driven. That means every PANTS application has a main event loop, and on each iteration of the event loop, all the sockets are checked for events such as reading, writing, new connections, that sort of thing, and then PANTS handles them appropriately. And finally, it's callback-oriented, and this is probably the most important point for someone that's actually going to use the framework because it describes the way that your code interacts with it. You define callbacks, and then you link those callbacks to events. So when a new connection is made, you'll want to execute some segment of code. When data is read from a socket, you'll want to execute some block of code as well. And this is a pretty familiar pattern to anyone that's ever done, for instance, any web programming. It's present in the browser and in most GUI frameworks as well. This isn't the only way to do network programming, but I find it's a pretty natural way to do it. So just before I go on, I'm just going to run through a very simple example, that of an echo server. For those unfamiliar with the concept, an echo server basically, a client connects and any data they send to it just gets sent straight back to them. So the first thing I'm going to do is just import the API, and then I'm going to define my class echo, which is going to subclass this connection class. PANTS defines a number of classes, connection being one of them, that wrap sockets and give you a sort of far more pleasant and suitable API for this particular type of design. I'm then going to override the onRead callback. This is a method that gets called whenever data is read from this connection. And as you can see, it gets past that single argument data, which is the data that was read. And I'm just going to write it straight back. And that's all the application logic that I need. So then I'm going to create a server, and I just pass it in this class, and I'm just telling server, which is another one of PANTS' built-in classes, to use this echo class to wrap new connections. And then I'm going to tell it to listen for new connections on a particular port and start the application. And that's it. Now, I should be able to run this. Connect to localhost on the port I specified. And anything I type gets echoed back to me. Oop. That's what I want. So that's a pretty simple example and pretty contrived, but it demonstrates this, the basic idea behind developing with Pants, which is that you define all your logic, you then have some amount of initialization, and then you start the event loop, and the event loop runs until you stop it somehow. So why use Pants in particular for this sort of thing? Because there are many great alternatives. I put 3 up there, but there are countless numbers of networking frameworks for Python. Async Core is obviously part of the standard library. Twisted, massive library that I think most people would be aware of. And Eventlet, somewhat less well-known library, but pretty neat as well. Async Core and Twisted use this same callback-oriented design that Pants does. Eventlet uses something that's more Greenlet-oriented, but under the hood, it's still the same asynchronous event-driven design. When I wrote Pants, I was aiming to build something that I personally would want to use. So I tried to make it simple, safe, and fast. I wanted something that I could use to throw together applications really quickly without sacrificing performance or flexibility. So it's simple, not just in the way you use it, but in the way it's written. The core is very small, it's under 1,000 lines of code, and it aims to just really cater to the most general use case by default. You can typically customize it to do more unusual things, but I wanted something that would let me do that without having to specify all sorts of extra stuff, like what host I want to listen on, whether I want a TCP or UDP socket, that sort of thing. And I think I've achieved that. What I mean by safety is that it completely, in most cases, covers the sockets API. So if you're not particularly familiar with sockets, you don't have to worry about doing something that's going to cause problems at scale or that's going to bring down your application just because you weren't really aware of what you had to do. And I've managed to do that, I feel, without sacrificing too much performance, although there is a bit of overhead involved. So I'm just going to run through some further examples now. The first one being what I'm going to call a message reader protocol. So something that you'll very commonly want to do with a networking framework is write a server that sort of buffers data that it receives until it gets enough of a meaningful chunk to process it. And Pants makes this easy through the use of a sort of magical thing, which can sometimes be dangerous, but it's called a read delimiter. So you can basically tell Pants, I want to read 2 bytes, or until I reach the next line break, or whatever comes up. And that will determine how data gets passed to that onRead method that I demonstrated earlier. So in this case, I'm going to write a protocol that understands a very simple message format, a variable length string preceded by 2 bytes, which we'll interpret as an unsigned short describing the length of the message. And what I'm doing here is sort of unusual, but basically I'm replacing that onRead callback at runtime with something else that I've defined here. And for the moment, I'm not going to put any logic in there. So these two are basically doing the same thing. just this is using a constant, and this is getting the length of the message passed into it. Now, when a new user connects, I'm going to read the length of the first packet or message. And so now, when a chunk of 2 bytes comes in, it's going to get passed to this method, onReadLength. And I'll just interpret that or unpack that data to be an unsigned short. And this struct is just part of the standard library. And then when I get a message in, this data is going to be whatever was specified in that 2 bytes of length. And we'll just print that out. And then read the length of the next packet. And then I'll just use the same initialization that I had there before. Start up the engine, start up the event loop. Now that looks correct. Okay, and I wrote something earlier that's going to send messages in this format that I've specified. And this is an example of a client using Pants. And as you can see, it's pretty much the same structure. There's logic, and there's initialization, and then the event loop gets started up. So if I run that, you'll see our server has received the message and printed it out to the terminal. Now, you can't really call yourself a networking library these days if you don't have an HTTP implementation, so Pants comes with one. It's really straightforward and pretty awesome. I'm just going to write a hello world server. So I'm just going to send the status, 200, send some headers, and then send my response. And then finish the request. Yes. The HTTP server is a bit different to the regular server in that you pass it a function rather than a class. You can pass it a callable class if you want. It doesn't really make much difference. But again, same basic application structure, logic, initialization. Now, there we go. Very straightforward. And of course, no Python networking library would be complete without a WSGI implementation. So there's a WSGI example. It's not too different from the HTTP example. There's just a little bit more overhead there. So Pants can do a lot, and there's a lot sort of in the library already. But at its core, it's really a generic networking solution. So you'll see I imported stuff from a contrib package here. Everything that's in the sort of root package is just really basic stuff for TCP, and UDP networking using Internet and Unix sockets. Part of the sort of coincidentally impressive part of Pants is its performance compared to other frameworks. We use benchmarking as a tool not only to gauge performance, but also to test the capability of the framework under strain. And here's a comparison of Pants to some other networking frameworks in Python. Up at the top, we've got Async Core, which is amazingly fast, really, but it's sort of getting a bit old. It's using some not so modern technologies, and it falls over under particularly heavy strain when there's many thousands of sockets connected to it. Whereas these other four, they use modern technologies that can handle many thousands of connections. So as you can see, this is what we call the fake HTTP benchmark, where we've just written a little server that returns a prefabricated HTTP response without actually processing anything that it gets. And under this scenario, Pants is delivering a little over 20,000 responses a second. And other frameworks are doing really well as well. There's Eventlet, Twisted, and Tornado there. The HTTP implementation is also extremely fast. That's it compared to Tornado and Twisted using Keep Alive. As you can see, it's processing requests at an extremely fast rate. That's it taking a request, parsing and processing it, and then returning a prefabricated response again. So it's not really doing much work, but it's nearing 10,000 requests a second there compared to Tornado's 5,000 and Twisted's 3,000 or thereabouts. And the WSGI part displays similar characteristics. Now, I seem to have run a little fast. That's all I really had planned to say, unfortunately. Thanks for coming and listening. Pants hasn't had much exposure, really, because it's just been something I've sort of messed around with in my spare time, but it's been really awesome to come talk about here at PyCon, so thanks a lot. And if there's any questions, I'll happily talk at you at great length. Yeah?
Do you support multicast UDP? Oh, sorry, two questions. That's the first one. And the second one is, what other platforms do you support?
What other platforms?
Well, does it just have to have a Unix base, or does it also work on Windows, for example?
It'll run on Windows, BSD, and Linux, and anything really that supports Select, which is pretty much everything. It runs best on systems that support modern polling techniques such as ePoll and KQ, which is that's getting into more sort of complex areas. But that's where it has the best support, because those are the systems that have system calls that can really support sort of thousands of connections without falling over. And Async Core doesn't support those modern polling techniques, which is why it will fall over when there's several thousand connections, even if there's only one or two actually doing any work. The UDP question, multicast. I'm not familiar with what multicast is. There is a UDP implementation, but we've mainly been focusing on TCP for the time being. Yeah.
I saw your Echo example skip over the IPv6 localhost. Do you have IPv6 support in Pants?
Not yet, no.
Nearest first. With your HTTP implementation for the client side, does it support proxies? And in proxies also that use passwords?
I didn't write the HTTP implementation. That's my co-author. I suspect that it doesn't. It's fairly basic, particularly the client at the moment. The servers were really been where the main focus has been.
Does it have SSL support in the client and or server?
It did, and then I broke it. And then we teared it out. And it's going back in soon. In fact, I was discussing with the co-author this morning about putting it back in. It's a bit tricky to sort of get correct SSL support in something that's also meant to be generic. You have to do all sorts of unpleasant monkey patching and stuff. So no, not at the moment, but it will. It will.
So is the project just 2 people? Are there any other contributors or?
The main 2 contributors are 2 people, yeah. But
Yeah.
there's a few people I know of that use it, and quite a few people hang out in the IRC room.
Hey, how do you choose which polling technology to use? Are you using libevent, or you just choose it yourself?
I'll show you.
Cool.
It's pretty basic. This is pure Python. There's no reliance on any C libraries or anything like that. So that's how we choose which polling technology to use. Check for what's there and use the best thing that's available.
Okay, cool.
So do I understand correctly that this on Windows would use the select
Yes.
mechanism?
Yes.
Is there any interest in using a more efficient asynchronous I/O
Like IO
system call?
completion ports.
Yes.
Yeah, I'd be interested in doing that, but I haven't really made it my focus for the time being. A lot of the recent work has been getting the underlying design working really nicely and finalizing the API. And once that's all done, then we'll probably start looking at getting more support for things like that, and also things like IPv6 and SSL and all that sort of extra stuff that goes on top. All right. Thanks very much for having me. It's been an awesome opportunity to come talk here.